Okay, hello everybody. Thank you for joining me. So this session is going to be about Oracle's automatic indexing, new in 19C. My name's Dave Kurtz. I'm an independent performance consultant. I've been working with the Oracle database for quite a while now, and I spend a lot of my time working with PeopleSoft ERP, and I write about it, and you can read what I've written at this website and on these blogs. And I've written a book about what happens when those two worlds collide. I'm a member of the Oak Table, which means that we stand for trying to bring some scientific rigor to how we go around Oracle administration in general and performance optimization in particular. And I'm an ACE director, which means that I like sharing what I find about it. So obviously anything performance related is of considerable interest to me, and anything which, and a lot of my time is spent adding indexes to systems sometimes and sometimes removing them. So anything from Oracle which claims it's going to do that for me is of some interest. Is it going to put me out of a job? Is it time to hang up my mouse and retire? Well, we'll see. Because that's what automatic indexing is promising to do. It's saying it will take on the effort of adding indexes to your data model based upon how your system behaves. It's a new feature in 19C, and let's be clear right up front, it's available on engineered systems only. So it's probably primarily aimed at the autonomous database, but if you've got any other engineered system, cloud at customer, you've got out and bought your own Exadata, you will have access to this in 19C as well. Let's be honest, the Oracle documentation on this topic is not particularly verbose. It doesn't spend a lot of time explaining how this feature works. But there is a growing body of research published on various blogs, some within Oracle, but frankly, most outside, which is what I referred to when I wanted to get this feature working. And my interest was, well, just how good is it? How clever is it at adding indexes? Is it going to put me out of a job? So I just decided to exercise the feature by setting up a test on Swingbench. And the result is I've produced a repeatable test that I can repeat on any version of the database and that anyone else can repeat on their version of the database. And I'm going to show you what I did. Let's talk about what is in the Oracle documentation on this subject. There's an entry in the Big Data and Data Warehousing Manual where they say it's going to create and drop indexes based on changes in the application workload. And it's going to help improve index manageability. And there's another entry in the new database features guide, and they say, it's for data warehousing and it's for OLTP. And it's going to improve performance through dynamically making changes to your database. That's quite a bold statement. They don't really say exactly how the decisions are made. And that's something I'd like to sort of just begin to reveal to you. Oracle have done a number of presentations. There's various presentations, specifically by Maria Colgan, that you can go out onto the net and you can find. It's quite clear that they did this as a part of autonomous database. We will look after the database for you. It's a shift from an expert system, we're perhaps used to the tuning advisor, to an autonomous feature. In the ordinary dictionary meaning of the word autonomous, meaning it's going to take action for itself. It is entitled to take that action, and it will take that action when it thinks it is necessary. It's all part of this self-driving, self-healing, self-securing, self-monitoring database. If you look at those presentations, it's quite interesting because they seem to show examples of packaged applications. There's an unnamed accounts receivable system where they give examples of automatic indexing change some indexes. And there's definitely an example based upon a PeopleSoft ERP system. I was quite surprised by that, because to make an index change in PeopleSoft is an application customization that has to be done through the application dev tool. So it's quite interesting that they suggest that you could let this feature off the leash on something as complicated as an ERP system. There are a lot of other commentators outside Oracle who have put a lot of effort into researching this feature and have been experimenting with it and blogging about it. Richard Foote, who indexing has always been his speciality, has blogged and continues to blog very extensively on this subject. There's a huge number of posts he's done that deal with all sorts of features and show how automatic indexing work. Frank Pasho in particular has said, well, has posted a number of blogs. I like this quote. It's definitely an evolution of the advisors that were introduced in the past. And there's a whole bunch of data dictionary views that will tell you a bit about what goes on. Tim Hall, who we've just heard from in the previous session, has also blogged on this. And he's talked about, in particular, the DBMS Auto Index package, which is used to manage the system. And that's not supposed to happen. And there's some blogs by Julian Donchev, and I've added my own very modest contribution to this. So how does automatic indexing work? It's an expert system. It's essentially built out of two background jobs that run every 15 minutes. There's a SQL tuning set capture process that runs every 15 minutes with a max runtime of 15 minutes. And it measures what's going on in your system. And then there's an automatic indexing task that looks at the load and says, what indexes should I add? And how good a job do they do? So it doesn't just say, this is the index you should have. It builds it, it sees whether it's effective. And if it is, it makes it visible. It puts it into production. And it will do this, if it's allowed, on your production system all by itself. The new indexes it creates are initially unusable, and then they're made usable but invisible to check for improved performance. And finally, if satisfactory, it makes them visible, so they're available to the application, available to the optimizer to use. It can also drop unused automatic indexes by default after 373 days, so that's a year and a week and a month. And optionally, you can have it look at any manual indexes which exist on the system and say, well, after a certain period of inactivity, they can also be allowed to be removed. So it creates this feedback loop, and every presentation you'll ever see about automatic indexing has this diagram on the left-hand side. It looks at what's going on, makes suggestions, tests the suggestions, puts them into production, and continues to monitor them. And it might change its mind in the future if that's appropriate. And although it takes quite a while for indexes to be dropped, part of the feedback loop is it will change its mind about indexes, or it will drop indexes that it thinks are not beneficial. So it's an autonomous database feature. It's an engineered system feature only. So it's not available on non-engineered, non-Exadata systems. It's definitely part of Oracle's self-driving aspiration. What I will say is it's absolutely part of the database. And like the real-time statistics and high-frequency automatic statistics collection I talked about yesterday, if you set this underscore parameter on, the feature works and behaves exactly the same on non-Exadata as it does on Exadata. Of course, you would never do that in anything other than a play database. It's completely undocumented and unsupported, but it is part of the database. But it's definitely aimed at scenarios where Oracle can take on part of the work, not for general databases. So how do you configure it? Well, there are no initialization parameters for a start. And that's because, again, it's aimed at the autonomous database where you cannot specify parameters. So everything is done through this PL/SQL API, and the DBMS auto index package has got these 5 functions in, and I'll show you some of them as we go. So I set out to build a test with Swingbench, which was written by Dominic Giles when he was product manager at Oracle. He's moved on now. And it produces a realistic and standardized load. So my first objective was to see, well, just how does this feature work? And then I started wondering, well, just how good is it? So you can download Swingbench from Dominic's site, and I've run this on Exadata. I've run this on various versions of Oracle running on virtual boxes. I built the virtual boxes with Fritz Hoogland's Vagrant Builder, and of course I've turned the Exadata feature on to make this feature work on a non-Exadata system, purely for test purposes. And if you run Swingbench on a Windows desktop, you get this GUI interface. I've mostly run it in the VM using the text-only interface. How do you build? How do you get it to work? Make sure you've got Java on your machine. Download the distribution from Dominic's site and unzip it. I like to increase the AWR snapshot frequency to every 15 minutes so that you get more statistics captured. The default is an hour, but for purposes of this test, I find it helpful. I've built the sales order entry benchmark in its own table space so that it's easy to drop and remove, completely clear away, and then I can build it again. And I build the SOE schema with all of the tables for the benchmark using the text interface builder. And it just logs in, creates the tables, populates it with some data, adds some indexes, does the stats, and you're ready to roll with the benchmark. All really simple. And what you get is 9 tables and 27 indexes, 9 of which are primary key. There are 6 indexes on foreign keys, and then there's another 12 indexes which are secondary. And that's a term which is going to become more important as we go. A secondary index is anything not involved in a constraint. One of those indexes is a function-based index to enable it to do case-insensitive text search. That's also going to be significant. So baseline test, let's just run the benchmark straight. I'll turn automatic indexing off if I've been using it already. And then I'm going to run Swingbench in character mode for an hour, and it chugs away. And you can see the number of transactions per minute and per second that it produces. Nice thing is Swingbench also produces a whole load of metrics in an XML file, and you can build a report on that file. And you do it like this. I find that it's easy to run the report to PDF process on Windows. And then you can look in the report and you can extract some metrics for it. And when I ran the baseline, this was actually run genuinely on a proper Exadata, not on a VM. I got this set of results. So you can see the average response time in milliseconds for 9 transactions in the benchmark. And you can see the number of transactions per second, a little over 1,000 transactions per second. Okay. So the purpose of an index is to help you find the data. as efficiently and quickly as possible. And so developers and DBAs, we add indexes to avoid or resolve performance issues because we want to reduce the cost of finding the data. And you tend to find that it's really easy to add a new index to a database. It's considerably harder to know whether an index is used and then what are the consequences of either removing it or changing it. Automatic indexing aims to take on this challenge but of course indexes are not free. They take up space. They take up time and effort to maintain them during DML. What Oracle suggests you do when you start an automatic indexing is that you remove all of your secondary indexes, anything not involved in a constraint, and then you let automatic indexing determine which indexes to create on the data model. That's quite a courageous thing to do, I think. I'll quote Frank Pasha again. This drop secondary indexes procedure in the DBMS auto package, it removes all of the indexes not involved in a constraint from a schema or a table. There's no intelligence to this package. It just goes through and says, this index is not involved in a constraint, I'll drop it, end. I'll quote Tim Hall. If you're feeling particularly brave, you can do this. But if you do it, you'll get a clean slate so that automatic indexing can start building the indexes again for you. I think that's very courageous. I really do. One of the things it doesn't do, for instance, is it doesn't check the status of the constraint. I could have a foreign key on a table, but it might be disable, no validate, rely. And I might have done that because I don't need to incur the cost of validating it. I can tell the database to trust me that it's there. But if the foreign key was enabled and it wasn't indexed, I could get TM locking when I update the primary key on the parent record, because Oracle then does a reverse lookup on the foreign key table. But if I've disabled the constraint, I don't need the index. And I might do that because I just want to do foreign key join elimination in a query. But in this case, the index is not going to be dropped by drop secondary indexes. So it's, I wonder if, whereas I think the index should be dropped if it's on a disabled constraint. The other thing is that automatic indexing does not create function-based indexes. It simply doesn't do it. You'll find a blog post from Richard Foote on this subject. But drop secondary indexes does remove them. So I think if you've got function-based indexes and you need them, and you'll have to determine for yourself whether you need them, you may want to do something to stop. You may want to either, well, if you're going to use drop secondary indexes, you're going to have to put your function-based indexes back because they will be removed by drop secondary indexes. You'll just have to know to take care of this sort of thing. So in my second test, I am going to drop my secondary indexes on my SOE schema. And here are my 9 tables. I'm down to 15 indexes. And that's the 9 primary keys and to the 6 foreign keys. The other 12 have gone. So what happens when I run the benchmark? No surprise. The performance has nosedived, a whole load of transactions. They've got a lot slower. And my TPS has gone from 1,000 down to 81. Not a big surprise, but it's a big drop. Is automatic indexing going to get us back? Well, let's see. So I'm going to create a table space for automatic indexing and tell it that it is that's the auto index TS table space, and I'm going to tell automatic indexing to use that table space, and I'm going to tell it that it can use 100% of the space in that table space. Again, this is something you wouldn't do on autonomous because you can't create table spaces. You can configure the retention periods for automatic indexing. Now, I'm only changing these to absurdly low values to trigger certain behavior in my test environment. Remember, the default retention period is 373 days, but I'm going to set it to 7 days, which suited me at the time I was doing the tests, and I have sometimes set it lower. So automatic indexes are retained for 7 days if they're not used, and afterwards they're considered to be dropped. And I can choose to have manual indexes included in automatic indexing, the ones that I've created myself. At the moment, I'm not going to do that. And automatic indexing, the task produces certain reports that are visible in some of the DBA auto index views. They're going to be retained to 7 days too. I can alter that. I can restrict automatic indexing to a particular schema. So I could have my application in several schemas, but I'm only going to have one particular schema, for instance, subject to automatic indexing. I could design the application that way. In this case, I'm only going to let it loose on the SOE schema. I'm now going to switch automatic indexing to implement mode instead of report only mode, so that it's allowed to actually create the indexes, not just generate reports on the indexes it would like to create. I can look at the auto index config view and just look at all of the config that I've set up just to verify the setting. There are also some hidden parameters. So the SMB $config view table is what is behind that configuration view, and there's a whole bunch of underscore parameters which are like initialization parameters, undocumented, not supported to be changed. I don't know what all of them do, but the highlighted ones control the frequency and runtime of the auto index task, and there are some thresholds to determine whether changes in logical I/O on a statement are considered to be an improvement or regression, or no change at all. So it's either a 20% improvement, a 10% regression, and it has to have an absolute difference of 100 logical I/Os. I do not recommend changing any of these at the moment. There's another view, auto index schedule control, so you can see the two jobs that are there. So you've got the automatic SQL tuning set capture task, runs every 15 minutes for 15 minutes. And then you've got the auto index task, which runs every 15 minutes for a maximum of an hour. This is the process that's going to create the indexes, decide to create the indexes, test them, and then make them visible. So one of the things you get out of SwingBench afterwards, when you run that report to PDF, is you get this graph of activity as well as the timings, and it shows you that halfway through the SwingBench run, suddenly we had a big increase in performance when automatic indexing created the indexes. So does it do what Oracle says? Yes, it does. It created some indexes, and my transactions per second went up from 80 to 150. Well, that's a good thing. But we're nowhere near the 1,000 that we had when we started. We have not got back to the original performance. Now, to be fair, SwingBench is a very well-designed and well-tuned benchmark. And it was designed by Dominic to be that. But automatic indexing hasn't put all the indexes back that Dominic created. So what did we get? Well, here are my 9 tables, and I've got 5 new indexes. 3 of them are visible and therefore are used by the application. 2 of them are not. So it created a new customer ID index. That was one that was there before. Great. You'll notice that the automatic indexes have a naming convention, sys, AI, and then a hash value. Looks a bit like a SQL ID, doesn't it? it's actually produced in quite a similar way. There's another one here on order status, which is visible. It's reinstated this secondary, oh, I should say, this index is just on warehouse ID now, whereas before it was on warehouse ID and order status. So it's only built a single column index. It's reinstated the sales rep ID index. It tried to create an index on product ID. There's already an index on product ID and language code. So this is actually what I'd call a redundant index, and it didn't make a great deal of difference. So it's remained invisible. But of course, it's still maintained by the database during DML. And it's also reinstated this index on category ID on product information. It was there before, but it hasn't decided to make it visible. So only 3 of these indexes are actually having any benefit on performance. The index name is determined by the sysop combination hash function. It's based upon table owner, table name, and index column list. And that means that if an index is dropped and recreated, or the same index is created on 2 different bases, because you're testing maybe in pre-prod and running it in prod, and AI makes the same decisions, the index will have the same consistent name. There's a blog there from Frank Pasha that explains how that all works. So what happened? What did automatic indexing do? There's a number of data dictionary views that explain how it made some of its decisions. Not so much how, but what. You've seen the configuration already. There's a DB auto index statistics view. So every time the auto index job runs, it reports how much space it used, how many indexes it created, whether they were visible or invisible. It says, oh, look, we got an 88% improvement. Well, it did. It went from 80 to 150. It created a couple of SQL plan baselines to stop negative regressions on certain SQL statements. Great, so it tells you what it did. You can see it loading the SQL tuning set there into SQL plan baselines. And here are the create table statements. You can see it created the index unusable, invisible, auto, compress, advanced, low, and online. Sorry, compress, advanced, low, and online. So auto tells you it's an auto index, and there's an auto index attribute. And you can see how it starts out as unusable and invisible. It verifies various SQL IDs. Did this change actually make it better or worse? Okay, so here I've got a SQL ID. The SQL plan hash value changed. The buffer gets went from 37,000 to 130. That's an improvement. This SQL ID, this plan hash value didn't change, therefore it's unchanged. This plan hash value changed, but the change from 46 to 4 is too small to be considered to be an improvement. It hasn't met the threshold. The plan changed here, but the logical I/O didn't change very much. So it's less than a 10% change. So it's considered to be unchanged. So the index wasn't beneficial here. It actually made it worse, but it's not bad enough to be a regression. And here, well, yes, the plan did change and we went from 150 to nearly 300. That does count as a regression. So it checks its work. This is part of the feedback loop in operation. Now, this testing mechanism generally prevents automatic indexing from creating A, indexes that are not beneficial, and B, indexes that are not used. It's not perfect. It's interesting that automatic indexing is mostly working on logical I/O, while the optimizer is mostly working on, well, entirely working on planned cost. And there are situations where the logical I/O can go down and the optimizer cost can go up. What happens when you add a hint that makes a statement go faster because it's forced a different execution plan? The chances are that the logical I/O has gone down, but it's almost certain that the optimizer cost has gone up because the plan has to be more expensive, because otherwise it would have been chosen naturally by the optimizer. So hints generally make cost go up. And again, Richard Foote has found a number of cases where this has happened to him, that automatic indexing has created an index, but because of the costing has gone up, it hasn't used it. Another more recent set of blogs he's produced also warn you to make sure that your statistics are up to date, because otherwise automatic indexing will not make the right decisions. So I've now got automatic indexes in place. I've run my benchmark again. I've ran it for the automatic indexes were now in place for the whole of the duration of the benchmark, by the way. And you can see that there's 4 transactions there in yellow in the last column. The runtime has gone back down. 3 of them are better than when we started. 1 of them is better than it was in test 2, but not quite as good in test 3. Some of them we've made no difference at all. And my TPS has gone from 81 to 137. Not bad. It's an improvement, but it's not the 1060 that we started with. So, given that my job in life is to do performance tuning and tune SQL statements myself, I started to wonder, well, could I tune them better than automatic indexing? Could I get back to original performance, or even better, by doing what I do? So the first thing is I put back the function-based index that automatic indexing was never going to put back. But of course, dropping secondary indexes got rid of. That got me a long way. That got me back to 761 TPS. So that's about 3/4 of where I should have been in the first place. I think what I take away from that is take special care of dropping your function-based indexes. And then I added another index on product information, on category ID, and that got me to 1097. So now, with just these 2 indexes, I'm better off than where I started. This is better than baseline. And of course, I've got rid of a load of other indexes that I didn't actually need. I kept going. I added 2 more indexes, and I got it up to 1160 TPS. So yes, you can probably do better than automatic indexing on your own, if you're used to doing this and you know what you're doing. And here are the final results. So most of my transactions are now doing considerably better than the baseline, and some of them are even, I don't think any of them are worse than the original baseline, and my TPS is at 1166. There's the same data graphically. So I'm doing better than where I started. The last test was to look at, well, what happens if I let automatic indexing manage my manual indexes? So this time, all of my indexes are in place. I'm not going to drop secondary indexes. And I've told automatic indexing that it can remove automatic and manual indexes after 1 hour, 0.0416 recurring days. You wouldn't do this for real. That's an absurdly low value, but I was trying to get the behavior to work in my test. So set automatic indexing off, put it into initially with report only mode, and then I ran swing bench for a while, and then I put it into implement mode. And what did I get? So I'm now down to 17 indexes. Automatic indexing has dropped 10 of those of my indexes. It hasn't built any new ones. Note that it's left that function-based index. It has left 5 of the 12 original secondary indexes. And it has dropped 3 indexes on the foreign keys, even though all those foreign keys are enabled and validated. So I now have unindexed foreign keys, which is an interesting decision. Unfortunately, the automatic indexing actions are not reported anywhere. It doesn't report any decisions to drop or not drop manual indexes. The only way I knew that I've had 10 indexes removed is because I've done a manual comparison myself. If you let this loose on, say, something like an ERP financial system, which will probably have thousands of tables, that is a huge task to track which indexes have been removed. And was it done manually or was it done by automatic indexing? Not sure I'd like that. And you can, but the other point is that here, during the test, the swing bench test, as these indexes were removed, rather disturbingly, the performance has gone down. It's gone from about 1,000 TPS down to about 500. That's a little concerning. And I kept running this for quite a while and collecting stats and restarting things. I couldn't get it to put any more of those indexes back. I didn't get it to create any automatic indexes either. So, just to conclude, yes, automatic indexing does do what Oracle claims. It does add indexes that do improve performance. There's no question about that. It's pretty good for a first release, I have to say. I'm impressed. I don't think it goes far enough in creating indexes. It's not aggressive enough about putting indexes in that improve performance. In my opinion, the dropping secondary indexes is too aggressive. There's no intelligence in it. It drops the function-based indexes. It takes no account of disabled constraints. It could be better, I think. Manual indexes, again, it looks like it's too aggressive about dropping indexes, but it's difficult to know what was dropped, and I've certainly not been able to work out how it worked out what to drop. So that's a bit of a mystery. It's a closed box. Autonomous it may be, but it doesn't tell you what it's up to. Could you use a blended approach? Well, you can't alter automatic indexes yourself. You can rebuild them, coalesce them, and shrink them, and that's it. It used to be that you couldn't drop them, but certainly in 19.8, and I think this has been backported as far as 19.5, you've got this drop auto indexes procedure. So you can drop an automatic index and recreate it as a manual index if you so wish. At the moment, I couldn't advise anyone just to let this off the leash, I have to say. I'm sure it will get better. It's pretty damn clever that it's got this far at all. I think it is possible to use this just as an expert system in report-only mode, but I think you'd have to say it's not fulfilling its purpose if you use it like that. It's just another cleverer version of the automatic tuning advisor. But I think Oracle have definitely established the direction of travel. This is something we're going to see develop. It's going to get better as the autonomous database develops. I think people are going to use it. I don't really see people putting this out on a big ERP on autonomous. You can run PeopleSoft on autonomous database now. I don't think you're going to run automatic indexing on that PeopleSoft system, but we shall see. Watch this space. So, am I going to have to retire because of this product? Well, not yet, but at some point, yes, I should think it will make me redundant. Anyway, that's the end. Thank you if you're still with me. I see we've got some questions. I don't know if the questions are now visible to you. So I will read them out. Is there a script to identify unused indexes for more than 365 days? Well, not that I know of. It's actually quite tough to work out whether an index has been used. It's not logged in any way. All you could really do is go through the captured execution plans. I suppose you could join, what I sometimes do is I join the ash data back to the captured execution plans, but that's not an absolute answer. It's only indicative because not all plans are captured by AWR. So it's not absolutely certain. And I think even automatic indexing recognizes this because it says, well, I think this is something to do, but now I'm going to go and test it to see if I'm right. So you've got this feedback loop of proposition, test, implement, watch that it actually works, and if not, change your mind. If you drop an auto-created index, is there a mechanism to stop it being recreated, or will it just reappear? There is a second parameter on the drop index function, and I can't remember whether you set it true or false, but you can say you are allowed to recreate this or you're not allowed to recreate this. But it is now documented, which it wasn't but until recently, but the latest version of the 19C doc does have this parameter fully documented. And that's my understanding of it. You can stop it being recreated. Have you seen it create composite indexes? By composite, I take it you mean multiple columns. Yes, I have. I think I have seen it create composite indexes. It isn't too keen on it. There is something about order of fields. I haven't tested it. There is a Richard Foote blog published in the last month or so where he does talk about recognizing that an index with a different order of fields is on the same, is or is not useful. I can't remember how that went. I haven't tested it myself, but there is some subtlety around that. I think the answer is this is going to keep developing. Oracle are going to continue to work on this, and it will get cleverer, and there will be more intelligence put into it. It's its first time out, so I think they need to collect some intelligence from the market, and they will learn from what they pick up through the market and through support and through interacting with people. And it's worth looking at, I think, as a way of suggesting indexes. You might run it in a test system and see how it behaves, and you might let it create indexes in that test system. Would I do it in production? I don't think I would. I wouldn't have the courage to do that. Why? Oh, there's a new question come in. Why Exadata only? I think it's autonomous. Autonomous is built on the Exadata platform. This is definitely, AutoIndex is about autonomous. And I think that's why it's an Exadata only thing. It's a sort of happy side consequence that if you've got your own Exadata system, that it will run on that. I mean, you've seen, I've just put an underscore parameter in there, and I've got the same behavior on very much non-Exadata systems. And if you were in my presentation yesterday, real-time stats and high-frequency automatic stats collection, they're also Exadata-only functions because they're primarily aimed at the autonomous database. That is not a technical decision. The underscore parameter shows you that it's actually a commercial decision that Oracle have taken for commercial reasons. These features are absolutely part of the database. It just so happens they only work on Exadata. Quite why? You'll have to ask Oracle. But you're now down to Oracle licensing. That is a question for Oracle. Okay. Any more? There's some chat.
You have 5 more minutes so somebody else can ask other questions, so we don't have to finish yet. if somebody has any other questions.
All right, I thought that was my lot. I had it down as 45 minutes, but if you want to ask more questions, go for it. I don't know if you can see the questions on the screen. I've got them on the shared screen. Yeah, Neil's right. Decision made at Redwood Shores. Please apply Redwood Shores for any answers, but don't hold your breath. Okay, so automatic indexing is not on by default. You choose to turn it on. And that's in contrast to real-time stats, and, which are on by default. And again, high-frequency stats collection. It's not on by default. You have to choose to turn it on. It's a conscious decision. I haven't tried it on partitions. Does it create local partitioned indexing on partition tables? Is a very good question, and I guess I ought to build a variant of the SOE benchmark with partitioning, which is something you can do. One of the options on the utility that builds the schema is create it with partitioning. So I could create it partitioned and I could see what happened. I haven't done that test. Perhaps I will before I do the session again. So I haven't tried it. Again, are you just going to let this? Well, you'd have decided whether you partition the tables. This is about partitioning indexes. My rule of thumb with indexes on partitioned objects. Obviously, local partitioning is easier to work with. You have a one-to-one relationship of table partition to index partition. But of course, if your partitioning key is not in your index or not near the front of your index, then you may find yourself having to probe every partition in the index to do a lookup. And if you've got a lot of partitions, that might not be a good thing. That might tempt you to have a global non-partitioned index. The trouble with global indexes is that if you do a partition operation like drop partition or merge partition or split partition, you end up invalidating the index unless you remember to do an update indexes option on the command, in which case there's a lot of extra work that goes on in maintaining the partition. So there's quite a lot to think about once you end up with partition tables. I don't know for sure what the answer is, but you can go away and do the test. I'll go away and do the test anyway. There's nothing to stop anyone here downloading Swingbench, building an SOE schema and doing this test for yourself. This started out with me just wanting to learn about automatic indexing. What is it? How do I make it work? And I couldn't find much in Oracle, and Google took me to all of those people who wrote the blogs that I referenced. I'm not claiming to see further, but I have stood on the shoulders of giants. And that did get me going with this feature. But I just encourage you to go out and play with this. And SOE is as good a way of playing with it as any. Okay, any more? Oh, we do actually have some more questions. Statistics on workflow tables are definitely off topic because we won't have time to do that today. That's worthy of a whole separate session. Yep, you're absolutely right. There's a report that you can generate that's kind of like the tuning advisor. The difference is that automatic indexing will take action. The slides will be available through the user group. I believe the video will be made available when this virtual conference is over, and the slides will be available on my own website shortly.
Yes, we have to finish now. Thank you everyone. Thank you, David.
My pleasure.
And see you somewhere else.
Thank you. Bye.
Bye.